All right, so the main focus is on commutative and associative. So first one we're going to do is the commutative, and we're going to abbreviate property, so just property, prop of addition. I'm also going to show you how to abbreviate, so you don't have to write that whole thing out. But commutative property of addition. All right, the way you can remember commutative is when you commute to work, it means you drive your car to work and drive your car back. That's commuting. Commutative means just like a car passes another car, you can move things around. So for example, if I take 3 plus 4, I can switch that into 4 plus 3, and in both cases, they're going to equal 7. So that is a legal move to do, and your justification is it agrees with commutative property of addition. Okay, let's do the abbreviation for this one. Write the word commutative again. This is commutative property of multiplication, but you can just put an X in parentheses. That's commutative property of multiplication. And this is something that I suspect you do anyway, because you tend to multiply what's convenient. So for example, if you have 2 times 9, the commutative property says you can flip it around into 9 times 2, and you're going to get the same thing because 2 times 9 is 18, and 9 times 2 is 18. So you can flip around multiplication anytime you want, anytime it's convenient. So remember, commutative is like cars, commuting, moving back and forth. All right, number 3, associative. We're going to do associative property of addition. Associative property of addition. So one of the funny ways to keep these straight, associative is like an association. An association has lots of people in it, people with arms. Associative property uses parentheses. It uses arms. Associative uses arms. So, for example, if I have 7 plus 23 in parentheses plus 4, associative property says I can move those parentheses without changing the order, and it still will come up with the same answer. So I can change it to 7 plus 23 plus 4, and either way, I'm going to end up with the same number. Well, we can test that theory. 7 plus 23 is 30, plus 4 is 34. On the right, 23 plus 4 is 27, and 27 plus 7 is also 34. So notice, unlike commutative where things change order, in associative they don't change order. You just move the parentheses. You associate them differently. So you move parentheses around. All right, number 4, let's abbreviate this one. This is associative. So the associative property of multiplication. So for addition, you would put a plus in parentheses next to the word associative or commutative. And for multiplication, you'd put a times symbol. All right, associative property of multiplication says if you're multiplying 3 things together, you get to associate any of them that you want. So here we go. 2 times parentheses 4 times 7 is going to give you the same number as if you moved the parentheses around the 2 times 4. And you can do that because it gives you the same number. We can prove it. 4 times 7 is 28. 28 times 2 is 56. Over here, 2 times 4 is 8. 8 times 7 is 56. So again, with associative, the numbers don't change order. You just use your parentheses to associate them differently. All right, this is our last property. This one's a bit weird. It's called the closure property of whole numbers. The closure property of whole numbers. So to understand the closure property of whole numbers, you first need to know what are your whole numbers. Your whole numbers start with 0 and go up. 1, 2, 3, and so on. They do. Whole numbers do not include negative, just positive numbers and 0. So that's what whole numbers are. Closure property means the results are limited. They're closed. So you have a limited group of results. So what does this one say? This one says if you, and we'll abbreviate this, multiply or add whole numbers, you get a whole number. If you multiply or add whole numbers, you get a whole number. So think about adding any two whole numbers. 2 plus 3, you're going to get 5. You're never going to get 2 plus 3 is 4.5. Whole numbers plus whole numbers give you whole numbers. Whole numbers times whole numbers also give you whole numbers. And that's what closure property says, is when you do those two things, multiply or add, you're going to get a whole number. All right, this is a definition of counterexample, and it's all one big word, counterexample. Counterexample. Counter means against. Example is an instance where it occurs. So in math, if someone makes a statement and you come up with an example where that statement isn't true, the whole statement's false. So counterexamples are very, very powerful. So counterexample is an example that proves something, an example that proves something false. An example that proves something false. A counterexample is not an explanation. It's just an example. So, an example of a statement I could make is all high school students have a dog. So do any of you not have a dog? Raise your hand. There's my counterexample. She says, I don't, and that means what I said is now untrue. That's counterexample. Another one might be all the factors of 8 are 3s. What would be your counterexample to all the factors of 8 are 3s? What are the factors of 8? 2 times 2 times 2, right? So your counterexample would be, no, because 2 times 2 times 2 is 8. So that's my counterexample. So on your homework, you're going to be asked to give a counterexample. All right, Roman numeral 2. And I added this because my last class had a little bit of trouble with some of the simplify problems. So Roman numeral 2 is simplify with a property. So we're going to have x plus 2 in parentheses plus 3 plus x. Okay, so to simplify this, you can use a property to move the parentheses where it makes sense, because you can only add numbers to numbers, x's to x's, right? So I can use associative property of addition to move the parentheses over. So they are around the 2 plus 3, because I can add numbers together. So 2 plus 3 is 5. Now I need to add the x's together. So I'm going to use commutative property, which lets me change the order. Commutative property of addition lets me push this x over to the front. So I have x plus 5, and now you can add your x's. X plus x is 2x plus 5. You cannot add an x to a number term. So that would be your answer. The letter term always goes first. The variable goes first. All right, let's do another one. X times 4 times 5. So you can multiply anything, but the number always goes in front of the letter when you multiply it together. So I need to get the 4 and the 5 into the front. That's commutative property of multiplication, which says I can move the 4 and the 5 to the front, and it will not change the amount, it will just change the way it looks. So that's commutative property of multiplication, and that lets me say 4 times 5 times x is 20x. We'll look at one more. All right, last one of these, and then we're done with notes. 8 times, in parentheses, 2x equals, parentheses, 8 times 2 times x. All right, first part of your homework, you're going to say which property it is that it's showing. So the difference between commutative and associative is commutative, things change order. Associative, the association with parentheses moves around. So first of all, is this commutative or associative? Which one is it? Which one has the parentheses? Associative, that's right. And then there's two of them, associative property of multiplication and associative property of addition. Which one is this? Addition or multiplication? Multiplication. So you can put a little time symbol. That would be your reason that that equation, the left equals the right. All right, we're going to do a little bit more practice here.